Hello everyone, this is Dr. Esperanza, and for today we're going to be working on the transformation of our quadratic equation depending on the changes that is happening in the vertex form of our parabola. At this point, we already know that we can solve our quadratic equation by factoring, completing the square, and using the quadratic formula. And we're also able to convert our standard form of our quadratics into its vertex form, so we can quickly graph the behavior of our quadratic function on an xy plane. And for today, we're going to be talking about how your parabola is going to change depending on how the constants a, h, k is also changing in your vertex form for your parabola. So the vertex form, as we all know, is given by a quantity x minus h squared plus k, where hk is the vertex of our parabola. And to find the changes in our parabola, if we modify the value of our k, it will give us a vertical shift in the parabola. So that means it could move up and down depending on the value of your k. And the value of your h represents the horizontal shift of your parabola. And we're going to see that in a little while how it affects the shape of our parabola by changing the value of our h. Well, not just shape, but the position of our parabola. And the value of our a, which is usually our quadratic term, determines how the direction, if it's going upward or downward, and also the width, or how narrow or how wide our parabola will be depending on the value of your constant a. So let's start with the first transformation. We'll work on the vertical shift of our parabola. So let's have our main function, and it will be represented by 1, quantity x plus 2 squared minus 3. And we know that the vertex of this parabola is at negative 2 and negative 3, because to read the vertex form correctly, negative h and k is just basically the opposite of h and the value of your k to find the vertex of your parabola. So that means if we're going to graph this particular vertex form, our parabola is opening upwards since a is positive, and the vertex is at negative 2 and negative 3. Now let's have a transformed version of this parabola by changing the value of the k, which is in this case negative 3. Let's have k at positive 3 this time. So the value of the a and the value of your h is not changing, but k becomes positive 3 instead of negative 3. That means our vertical shift from our blue graph to the green graph is going to go upward, where the vertex is now at negative 2 and negative 3. So notice that the parabola has the same width, same opening, but the vertex is now above our main function because our k is changed from negative 3 to positive 3. So for the sake of argument, if we have another example with the same a and h, but the k is at negative 1, that means our vertical shift from the blue graph to the pink graph, it's still going to go up, because from negative 3, it will go up to negative 1. So that will be the vertical shift of our parabola. So if I have y equals 1, quantity x plus 2 squared minus 4, so this time from negative 3, which is the blue parabola, the purple parabola with k at negative 4 is going to be at the bottom of the blue parabola because k is now at negative 4. So notice that there's no changes on the value of our x, but just the value of the height of our parabola, which is represented by k. So this is the vertical shift of our quadratic equation on vertex form. Now let's move on to the horizontal shift. And this particular shift is happening when h is being changed. So it's going to be this main graph, again, the blue parabola represented by y equals 1, quantity x plus 2 squared minus 3, with vertex at negative 2 and negative 3. Now, from this main blue parabola, let's name it blue parabola, let's have the green parabola at y equals 1 quantity x minus 2 squared minus 3. Notice that a is still at 1, k is still at negative 3, but h is now at negative 2. So from positive 2, now it's negative 2, and we know that our vertex now is going to be positive 2 and negative 3 because opposite of h and k is the vertex of our parabola. So from the blue parabola, our horizontal shift is to the right, which is the opposite side of negative 2, or from negative 2, because horizontal shift is happening when h is changing. So if we have another set of parabola, which is the pink parabola, with h at negative 4, so opposite of negative 4 is positive 4. So that means our new vertex is positive 4 and negative 3. So from the blue graph, it will go further to the right, and it will move right here where our vertex is now at positive 4 and 3. And for our third shift, we have the purple parabola. A and K will be the same, but H is now at positive 4 from positive 2. So that means opposite of positive 4 is negative 4. So our shift in our parabola is going to the left. And now the purple parabola is right there that you are seeing in our xy plane, and this is how your parabola is changing when your h is being transformed. So notice that it's just moving from left to right depending on the value of h. And this time, let's talk about the changes that will happen when the constant a, or quadratic term, is going to change, or the coefficient of our quadratic term is changing. So we're going to be using the same main function, which is the blue parabola, and the new green parabola this time will have a different value of a. So h and k will still be the same. It's still going to be at negative 2 and negative 3, because we did not change it. But now we are seeing a negative 1 as a coefficient of our quadratic or quadratic term. So our changes is going to happen on the direction on how your parabola is opening. So from opening upward, now it's opening downward, but the shape of your parabola, how narrow or wide it is, it's still going to be the same. And the vertex, it's still going to stay at negative 2 and negative 2 and negative 3. So that is our shift when we change our value of a. So if I have y equals 8 quantity x plus 2 squared minus 3, notice that from 1, now our a is a little bit bigger, which is at 8. Now the question is, do you think that the parabola is going to be narrower or wider? So we're going to see it in the next graph. So notice that now our parabola is not just shorter, but narrower. So the parabola becomes a little bit slimmer when the value of your coefficient a is getting bigger. That means if our a is smaller than 1, which is 0.005 in this particular value, not negative, because if it's negative, it's going to go downward. So let's see what will happen to our blue parabola when the a value is changed from 1 to 0.005. And now we are seeing that the parabola becomes wider because our value of a is now smaller. So that's how the shift or the shape of our parabola is changing when a is transforming. So as a go bigger, the parabola goes slimmer, and when a becomes smaller, the parabola becomes wider. And the direction of your parabola is determined by the sign of your a. So let's take a look of an application which is a little bit better than what I did on my presentation or my slides, because I just formulated it. But this time around, we're seeing Desmos, and Desmos has a better application, so we can observe how the transformation is changing when a h and k is changing. So notice that a, this is a positive a, that means it's opening upward, but if we change it to the left, it will go downward because now it's negative 0.7. And we know that when your parabola is going further away from zero, our parabola is getting slimmer. And when it's go closer and closer to zero, our parabola is getting wider. And when the parabola becomes positive, or our a constant becomes positive, our parabola is going to go up, and it will go slimmer if we move it further away from the point of origin, or zero. So that's how the parabola is changing when we are changing or transforming the value of our a. Once it's going further and further and further away from zero, the parabola is going narrower. And when it's closer to zero, the parabola becomes wider. And when I say it becomes closer to zero, that is the value of a. So that is our parabola opening upward. Now for h, we know that h is right next to x. So that means the changes is going to be horizontal because h is with k. So that means if our h is changing, the horizontal transformation is going to be evident. And h is determined by the horizontal shift of our parabola. So when we have our h going further and further away from zero, it's going to go further and further away from the left side or the right hand side of our parabola. And when we change our k, so if we have a positive k, it's going to go above the x-axis. And if we have a negative k, our vertex is going to fall below the x-axis. Now, the opening of your parabola, it will be determined by how your a is changing. So remember that your constant k is just changing or transforming the position of your parabola, but not the direction on how your parabola is opening. So this is how we are seeing the transformation on our parabola by changing the three constants that we are seeing in our formula in the vertex form of the parabola, a, h, and k. And it's important that we know how this is happening because on the next challenge that we're going to be working on, we're going to be seeing how we can construct the equation of our quadratic equation by just looking at the graph, and knowing how the parabola behaves will give us a better chance on writing out the correct equation for our quadratic function. So for our Numberbender challenge for today, what I want you to do is go to Desmos and play with the application so you can have a better understanding on how your parabola is transforming based on how you change your a, h, and k. Because it's important that we're not only understanding how to solve quadratic functions, it's also important that we are seeing and visualizing in our head how the parabola is being graphed on the xy plane. So this is our lesson for today, working with the transformation of our quadratic equation by changing the value of the constant in our vertex form a, h, and k. So this is Dr. Esperanza, and see you again next time. Bye!